So as we move on to assignment number 6 in Unit 6, we're going to be graphing both sine and cosine curves. So we're going to get an idea of what that looks like and then how we can change those curves, change the magnitude and the period of those curves. And so I'm going to go back to the unit circle and how we talked about how that the y value is always equal to the sine of the angle. And so here, the sine of 0 degrees is right here. The sine of 0 degrees, I'm just going to go through each of these marks. This is like an x and y axis right here. Here's the origin. So we have the point 0, 0 here. What I'm looking for in the sine of these angles is the y values. And so here the y value we know is 0. And so it's going to start at this point. But then by the time I get to 30 degrees, which is right here, the y value is a half. And so I'm all the way up at 30 degrees, I'm up to a half. And when I get to 45 degrees, that's the square root of 2 over 2. If you look at your unit circle, it's going to be hard for me to write here, so small. But the square root of 2 over 2 is about 0.7. So we had a point here at a half. We have another point here at about 0.7. I like to be able to keep those on there. When I get to 60 degrees, it's the square root of 3 over 2, which is like 0.86. We're all the way up here now. By the time I get to, so it's this distance. By the time I get to 90 degrees, the sine of theta, the sine of 90 degrees, well, that's 1, which is right here. So I kind of went up like this. Okay, so I'm looking at 0. I'm looking at these vertical distances, and they go up to 1. And then when I get to 120 degrees, I'm back to the square root of 3 over 2. When I get back to 135 degrees, it's the square root of 2 over 2, which is 0.7. When I get to 150 degrees, I'm back at a half. So I'm back at a half right here. And then when I get all the way to 180 degrees, the vertical distance is back to 0. So it went all the way up, and then it comes all the way back down at 180 degrees. Now remember, 180 degrees, this is the same thing as pi. So this would be the same thing here as pi over 2. Well, now what happens as I continue to go around the circle? By the time I get to 270 degrees, I'm at negative 1. But these values are a half, 0.7, 0.86. So a half, 0.87, 0.86. And then as I continue to go around, these are the vertical distances. They're negative. Finally negative 1. And then I go kind of back all the way to 0. And so you can see all those vertical distances. I could draw these vertical distances in here just like I drew them on the unit circle. Here's 0.7, here's a half, and here's 0 again. So between 180 degrees and 360 degrees, all of those distances are negative. But between 0 and 180 degrees, all those distances are positive. Okay? So that is why the sine curve looks like that. It just starts out at 0, it goes up, comes back down at 180 degrees, it crosses, goes back down to negative 1, and comes back up, and at 360 degrees, it crosses again. Then it just repeats itself. So I go around 360 degrees, and I can go around again, and this curve continues forever in this direction and forever towards the left. And it's called a sine curve. A lot of times it's called a sine wave. That starts at 0 and goes up and down. Let's compare that to the cosine curve. So remember that we talked about the cosine curve. The cosine of theta are your x values. So cosine of 0 degrees, here's my x value, that's 1. And so the cosine of 0 degrees starts at 1. By the time I get to 30 degrees, the x value, that's this distance, is the radical 3 over 2. That's the 0.86, which is about here. Then by the time I get to 45 degrees, the x value, that's the distance going, that's the horizontal distance. That's square root of 2 over 2, which is about 0.7. By the time I get to 60 degrees, it's a half. And finally, by the time I get to 90 degrees, that's the x value is 0. And so by the time I get to 90 degrees, it's basically come back down. It's gone all the way down to 0. Now what happens with the x values from 90 degrees all the way around to 270 degrees. It starts at 0, then it's a half, 0.7, 0.86, 1, 0.86, 0.7, a half, and 0 again. So here's where it's -1, that's 180 degrees. It's a half, -0.7, -0.86. So in other words, it comes down like this, and it comes back up to 0. Then from 270 degrees to 360 degrees, starts out at 0, goes up to a half, 0.7, 0.86, and back up to 1, which means it does something like that. So it's the exact same shape really as a sine curve, but it doesn't start at 0, it starts up at 1. And it goes down to 90 degrees. Here is 180 degrees, back up at 270 degrees and 360 degrees. Now remember, this could also be considered pi. This would be 2 pi. This is going to be 3 pi over 2, and 90 degrees is pi over 2. So those are the critical points in the cosine curve. All right, so that's and by the way, this also you can go 360 degrees and continue. So it would come back down here. It would come back down. It's just kind of a cosine curve. A lot of times this is also called a cosine wave. The only difference between the cosine curve and the sine curve is that the cosine curve starts at 1 and goes through 2 pi, goes through an entire period from 0 to 2 pi or 360 degrees. That's called a period, because then it starts that period over again after 2 pi or after 360 degrees. Where the sine curve, if I go back, the sine curve, also this is called a period, and it starts at 0 and it comes back up to 0 and starts that period over again after 360 degrees. Another vocabulary term we should probably know is the amplitude. The amplitude is how high does it get. So a normal sine curve and a normal cosine curve goes from +1 to -1. And so you can see the same thing is true on the cosine curve. It goes from +1 down to -1. So let's start looking at graphing these things by changing at least the amplitude. So if I were to graph just y equals the sine of x, I would start at 0, and I would go up at pi over 2, which is, I would be at 1, and then by pi, or 180 degrees, I'd be back down to 0, then I'd be down to -1, and then back up to 2 pi again. That is a period. Then it would continue. Same thing going back this way. Okay, so the sine curve looks like that, and it goes forever to the left, forever to the right. The amplitude is 1 because it goes from +1 to -1. But what I'm doing here is I'm taking all those values of the sine of x, I'm just going to multiply them all by 2. So when I get to 1, I'm not going to be at 1 anymore, I'm going to be at 2. And this new curve is going to look like this. It's still going to start out at 0, but instead of going up to 1, it's going to go up to 2. It's going to be at 0 again. Instead of going down to -1, it's going to be down to -2, and then back up to 2 again. And it would go like this also in the negative direction. And so by having a 2 here, it just changes the amplitude by 2. A lot of times your voice, that's a sound wave. And so the amplitude is how loud you're speaking. And so if you increase your volume and start yelling, you're increasing your amplitude, and it's just becoming louder. So if I have 3 times the cosine, let me go ahead and start again with the regular cosine curve. Cosine, remember, started at 1, and by the time we got to 2 pi, it was down to 0. By the time we got to pi, it was at -1. Then it went back up to 0 at 3 pi over 2, and by the time we turned to 2 pi, it was back up to 1 again. That's one period, but it would continue. And the same thing would happen in this direction. And it would just continue forever to the left and forever to the right. But if I multiply that by 3, let me go ahead and change this, and I'm going to graph this in a different color. So instead of starting at 1, I would take the cosine value, which is 1, and multiply it times 3. I'm going to start at 3. And by the time I get to pi, I'm going to be down to -3. Then I'm going to be back up to +3 again by the time I get to 2 pi, and it's going to continue. Same thing in the negative direction. It's going to come down and be at -3 by the time I get to pi, and it's going to be up at +3 by the time I get to 2 pi. And the amplitude has been tripled by multiplying it by 3. And so we would say the amplitude here is 3, where over here we would say that the amplitude for this problem here, the amplitude is 2, when normally the amplitude is just 1. Let's talk about one more thing here, and that's the period of these curves. So normally, here the amplitude is 2, so we know we're going to go up. I'm going to use my regular color again. The amplitude is 2, so I'm going to go from 2 to -2, but we have 3x here. So what that means is that the problem is going to there's going to be 3 periods within the 2 pi. In other words, when I put a pi in, I'm just going to multiply it times 3 pi. So what's happening is that I'm taking the normal degree measure and I'm multiplying it times 3. So if I were to stick in pi over 2 as my input, I would actually be at what's normally happening at 3 pi over 2. So we know that the normal curve looks like this. Oops, I messed that up. Let me erase that. The normal curve looks like this, where it comes up and it comes back down at pi and then goes to 2 pi. Well, what's normally happening at 3 pi over 2 is actually going to be happening at pi over 2. Because I'm taking pi over 2, that's my x value, but I'm multiplying it by 3. So it needs to be on its way back up at pi over 2. And the amplitude is 2, so what's actually happening here is something like this. It's going to come up, it's going to go all the way up to 2 and back down, and it's going to be on its way back up at pi over 2. Now it still has to finish this. There's a period. It's going to be down at pi over 2. So from here to here is one period. And so what's actually going to happen is it's going to go through that process 3 different times by the time it gets to 2 pi. And so our normal period is 2 pi, but it's going to happen 3 times in that amount of time. So our period now has a length that is 2 pi over 3. In other words, by the time it goes down, up, down, and back up, this value right here is going to be 2 pi over 3. I probably should have picked different numbers to work with. But it happens is there's 3 periods within the same time or within the same x-axis as what normally happens with 1 period. And it'll be the same thing going backwards. There's going to be 3 of these by the time we get to -2 pi. Maybe this will make more sense with this equation. Here it's 2x, and so that means I'm going to go through 2 of those periods by the time I get to 2 pi. So with cosine, I start at 1, except this time I'm going to start at 4, and I'm going to go through an entire period between where I'm at, it goes down to -4, and 3, and pi, because that's the period here is just 1 pi. I'm taking 2 pi, the normal period, and I'm going to divide it by 2. And so then it'll happen again, and by the time I get to 2 pi, it goes through that process twice. This is really ugly graphing, but hopefully you get the idea here. And the same thing goes backwards. By the time I get to pi, I'll have 1 period, and then I'll have another period by the time I get to 2 pi. So this changes the period, and I always will take 2 pi, which is the normal period, and I will divide that by whatever I'm multiplying the x by. And so here, if I'm multiplying it by 2, then an entire period will go from 0 to pi, and so it's 180 degrees in length. So on our homework assignment, we're graphing these equations, but we're going to take a look specifically at their amplitude and their period and how that changes, and we should know that they're curves. So this is what your homework assignment is about. We will go over this more tomorrow, and we will see you then.